Aloha, Rich Halverson here. This is its388al, and in this video, I'm going to go over assignment 3, which is to enhance our MIPS Python simulator with the multiply instruction. So, share my screen here, and here we are. It's this assignment, and so we can look in section 3.9 for a description of the multiply instruction. And what the multiply instruction does is it multiplies two registers together and stores the result into a third register. Okay, so that instruction is, it turns out that the MULT instruction is actually, it's actually what's called a pseudo instruction. And what that means is that the assembler actually breaks this instruction down, actually breaks it down into two smaller instructions. Those instructions are the MULT, which multiplies two registers together and stores them in this additional register, this extra register called the low LO register, which is low. And then if the result is bigger than 32 bits, then it stores the upper part in this HI register. So we are not ever going to multiply numbers that are so big that we have to worry about the HI register. So everything we multiply is going to just, we're just going to need the LO register. And so what this MULT, what this instruction translates to is this instruction followed by this, which is move the lower register into a register. So it's A times B, and the result goes into C. It's that kind of thing. So let's see this happening. Okay, I'm going to start with our old with the simulator that we just finished in this last assignment, and let me just run this. It's Python 2C, MIPS 2C simulator, I believe. And basically what it does is you can see that I'll go back to the code here. It loads up T6 with 5,000, which is going to be an address register. It's going to point to a data memory address. And then T5 is going to be loaded up with an ending address. And all this, and what this code is going to do is it's going to load from memory location 5,000, which happens to be 22. In the simulator, we load it with 22 as a starting value, load it, and then we double it using T2, T0 plus T0, starting in T1, and then we store T1 in the next address. So we aren't storing it, we're storing it at 4 plus 5,000. So we're actually, in the first time we're doing it, we're actually storing at 5,004. And then we increment this address register, that's T6. So now the address register is not going to point to 5,000 anymore. It's going to point to 5,004 without the offset. And then we test to see if this address register has reached this value. And that's what this does. If it has reached that value, if it's equal, then it's going to skip to the end label, which is down here, which is the end of the program. Otherwise, if it's not equal, it's just going to go down and execute the next instruction, which is jump back to here, which we loop again, each time incrementing T6 until we reach this value. Okay, so that's what the last program did. And so you should see that we used the assembler to produce this machine code. And then we added, we added the jump instruction. We added the branch if equal. Okay, so let's start with so I'm going to take the old simulator. I'm going to save as, and I'm going to call this multiply 3A. I have a 3 already, so 3A simulator. So this is my assignment 3 simulator. And let's see what we have to do. If we go back to assignment 8.7, this is where we did the volume of a rectangular box, and basically we had a length, a width, and a height, and we those who had values in them, and we multiplied these three together to get a result which we stored here. In the code here, let's see, I'm going to modify this program because I'm not going to bother with the stuff that's outside. Let's see, I'm going to where is my notes for this? Oh, let's see, I'm going to create a new program, and it's going to be very similar to this, except for I'm not going to load T1, T2, and T3 with values from memory. I'm just going to load values directly into T1, T2, T3. In fact, I'm just going to load 5 into T1, 4 into T2, and 3 into T3. And then I'm going to do the multiply, and the result's going to be in T4, and that'll be it. Okay, so I'm not going to bother storing this out. So basically, it's going to be a program that looks like, let me start again. Where's this? Okay, this is the end of this code. This is okay. So I'm going to start a new, I'm going to make a new program, and it's going to be, something like, first I'm going to load ADDI. First I'm going to load T1 with 0, comma, and I'm just going to load the 5 right in there. Okay, so this is a length. And then I'm going to add, or I'm going to load into T2 the value 4, 543. Okay, and this would be the width value. And this is from, the assignment 8.7. And then add into T3, I'm going to load in there 0 plus 3. So, and this is going to be the height. Okay, and then I'm going to just do, it looks just like this. I'm going to do these multiply instructions. And I think that's it. See what this does for me. Okay. All right. And so when this is done, we should see 60, the value 60 in T4, right? So let's run this to make sure that this program is correct, the simplified program, copy. And I'm going to go over to section 310 of our textbook. And I'm going to go down to the third simulator because that's with assembler. And I'm going to just paste my program here. And then I'm going to just simulate it. Okay, so I'm just going to enter this, assemble it. Looks like this. And oh, by the way, notice that these MUL instructions actually assembled to the MULT and then in the MFLO. Move move lower. And this MUL translated into these two instructions. Okay, so anyway, let's execute this. I'm gonna enter the simulation. I'm gonna put it on fast, and let's just run it. You see the 5 gets loaded, the 4 gets 3 gets loaded, and then the multiplication happens. 20 is the first one, and then 20 times 3 is 60. See, so first we multiply the 5 times the 4, and that's why you saw the 20. And then we multiplied the 20 times the 3, and that became 60. So this executes the multiply instruction just like our assignment 7 did. Now if we look at the bits, the assembled bits, it looks like this. So this is the program we want to execute. I'm going to copy this out. And I'm just going to paste it here. I'm going to, I can do this. And I'm just going to paste this thing here, because this is really the program we're going to want to execute. And now I got to get something that looks like this. And so that's going to be, I guess after here, I'm going to go back to here and go to bits. I'm going to copy the bits, copy. And I'm going to go back over here and I'm going to paste the bits right here. Just go paste. There they all are. Okay, the first thing I got to do is I got to take out all the blanks, copy this, do Control H. This is a notepad, and most editors have this feature. I want to replace all of the spaces in the selection with nothing. Placing the spaces in the selection with nothing. Replace all. Boom, they're all gone. Great. Now I want to replace in the selection, I'm going to include that top line there. I want to replace extended. I'm going to replace the \n, get rid of the space, \n, which is a new line, with new line, this I am, and I'm going to have to put the numbers in myself. I'm just going to, I am 0 equals, that's what I want to replace it with, because I want it to look like this up here, see? So let me just replace all. Oh, shoots. No, that's not what I want to do. Control Z. Oops, go back up here. Control Z. All right. I forgot to do the in selection, I think. Oh, yeah, I forgot to do the in selection. Don't forget to do the in selection. In selection. Now try it. There we go. Didn't get the top one there. I didn't undo. It's wrong. Let's do the in selection again. Control H. It's not \n, lowercase n. It's not this, I need to put the 0B in front of, see, there's a 0B there, see? So that's what it's gotta be. And now let me do in selection. Oh, it's not in selection, the control N to that, replace all. Huh. I don't know why it does that. Undo. Let's try this again. All right, one at a time. All right, done with that. Let's make this down, oops. Down, back 1, down, back 2, down, back 3, down, back 4, down 4, 5, 6. So it's just 0 through 6. That's 7 instructions. We've got to put this NPC thing in there, and let's make it NPC equals 7. NPC equals 7. All right, just like this one, except for it's one less. Okay, now we got to indent this, so it's Python's got to be indented correctly. Okay, here's our new instruction. Here's our new instructions. And we need to be able to recognize, okay, so we need to also add the load here where we initialize all these registers. We need to initialize the low register equals 0. And this is the lower half of the product of a multiply. And then we're going to do HI, which is Initialize that at 0 is the upper half, which we're never going to use. Let's put that there anyway. Okay, so we've done that, and now let's add these instructions, and we got to be able to recognize this. Okay, this instruction's new. No, I'm sorry. These two instructions are new, and these two. So we have to be able to recognize the MULT and the MFLO. That's these last two instructions. It's also 3 and 4. Okay, so let's start by modifying one of these. Let's take the add I instruction. If we look at back here, we're actually doing the MULT and the MFLO. Okay, so we look at the colors here, and I hope you're not colorblind. T1 and T2. So T1 is the second set of these are 5. 1, 2, 3, 4, 5. That's T1. And it looks like this is T2 by the green. And then for the MFLO, the only one that we care about is really this one. Okay, so these happen to all be zeros. Interesting. The opcode is 0, and these are 0 for whatever reason. Here's like this function code. These sort of modify all of some of these instructions that don't use all the operands. Anyway, so when we have a T1, a T2, and this would be a T3. That's like the add instruction. Yeah. Add. It's almost like this add instruction. This is the first, the red, the green, and the orange. And the orange. Okay. Red, green, orange. Anyway, so good. I'm going to start with the add instruction and mess with that. Okay, where's add? Here it is, this instruction. So I'm going to do this. I'm going to do copy. Copy, and I'm going to paste it. Go up one. I'm just going to do Control V to paste it. Okay, and this is going to be my mul. This is going to be the mul instruction. And this has got to be different. The mul instruction, the first part is this. No, yeah, the MULT. Yeah, MULT instruction. We need to have this in the beginning. Mul. We need to have this in the beginning, don't we? Paste. Yeah. And then at the end, this is 5 to 0. These are the last 6 bits. This is the first 6 bits, 31 to 26. We need MULT is we need these. And I'm not going to worry about these 2 sets in there. I don't think I got to worry about them. In future instructions, I might have to go and be more specific and clear that up. But right now, I'm just going to. Okay, so this looks like this now will recognize the mul instruction, and it's going to be multiply MULT. I'm just going to do RS and RT. And so the first 25 to 21, it's the same as the add. It's this red one. I'm just going to leave that. 25, and then the next set is 20 to 16. That's this one. That's the green. That's fine. So that means that add one is the first one is. Oops, gotta get down here. I'm doing multiply. Shoot, let's put this up here. Add. So this is the contents of the first register set. The first register. This is the contents of the second register. And we're just going to say LO because we're putting it into low. Low equals add 1 times add 2. Okay. And I don't think we need an RS. It's Oh, it's our S and R two. Okay, we named these differently. So this is really, oh, 25 to 21 is RS. Yeah, and we don't need this one. We're not using this one. And this is MULT. No, MULT. And this one and this one, and we don't need this last one. Okay, that's mol. And now we're gonna do MFLO, which is kind of like the rest of the rest of it. It's the storing into RD into this one. So what the heck? I'm just gonna start the same thing again. Kind of go through the same process, starting with add. And I'm gonna put it down here. Yeah. So this is gonna be MFLO, MFLO. And it's gonna be MFLO, MFLO into actually the destination register. So I'm just going to do that. Okay. And we don't need this anymore. We don't need this anymore. What we do need is to load into 16 into the third set of from our this, not the opcode, not the first register, not the second register, but the third register, which is the third one. That just needs to be loaded with low, LO, contents of low. Oh, okay. And this is, lower half of MULT instruction, lower half of product MULT instruction. And the opcode is going to be, oh, I got to set these opcodes up. So what are the opcodes? It's a MUL, MFLO is 000. Okay, so let's put that in there. This is, okay, it's all zeros. It already is all zeros because it's the same as add. Yeah, okay. And then the last one is these. Copy this, and MFLO is the end should be this. Okay. And that's the beginning and that's the end. And then that's this and this and this. And we don't need these two. Don't. So, and this is going to be MFLO. MFLO. The destination is here, so I'm just going to get rid of all these. Is that right? I think this is not right. This should not be 15 and 11. This should be 20 to 16. This should be here. Yeah. This maybe it should be reversed or something. Anyway, I don't think it matters. It doesn't matter because it's a multiplication is commutative. So and then here we just need the destination, which was this one. So this time we can get rid of these. Hey, you got that? Let's this could be right. Okay, so this is the okay, 20 to this one is it's the MULT we're doing. T2 is second, T1 is first. Okay, let me just do this the way this is. So this is T1. I'm going to take this thing and put it here. And I'm going to got to put a comma there. Okay, so this is the closest one, and then this is the next closest one. I think this is gonna be the closest one, next closest one, RS and RT. Yeah, RT is the second one. So that's the multiply, and then the MFLO is just simply taking whatever what was in here. Here we stored it into LO, and we grab it back out again and put it down into this destination down there. All right, so this is it. I'm going to save this, and I guess I can just see if this thing runs. I don't know if it'll run or not. Okay, so let me go here. Let me do CLS to clear everything out, and I'm going to do Python 3 MIPS 3. This was 3A, right? Tab, and T4 did not get. T4 is supposed to be 60 or whatever it is. It's not. T4 after this one is supposed to be 20 because it's 5 times 4 and it's not. So these all get loaded. 5, 4, 3, those get loaded, but the multiplies don't work. Let's see, in the MLO we have. Did I do something wrong? Okay, MLFO, FLO, R15 gets low. And in this one, 25 to 21, 20 to 16. Low gets add 1 times add 2. All right, so the problem is that we have the mul instruction. It's actually MULT, okay? The MULT instruction here, remember we're implementing the MULT instruction and the MFLO instruction. According to this, the opcode for the MULT instruction is 000100. And but according to this, it's 000000. See, the MULT instruction is 000000. The end is correct. It looks like 11011100. 01100. But this is wrong. Well, either that or this is wrong, but we're trying to recognize this machine language. So to fix that, I just simply we're not looking for 000100. We are looking for 000000. That, and that's our MULT instruction. So let's save this now and run it. I'm going to do a CLS again to clear it. And if I run it, no, not 2C, 3A, here we go. So we see that 5 times 4 times 3 is 60. That was at this one after we load 5 into T1, which is now there's a 5. We load 4 into T2, and that's why there's a 4 there now. And then we load 3 into T3, and that's why there's a 3 there now. And then we multiply T1 times T2. Yeah, we multiply T1 times T2, 5 times 4, and store the result in this LO register. Then we grab out this LO register and store it into T4. So here we see the 20 from 5, that's 5 times 4, which was in the LO register. And then we want to take T3 times T4, and that's in the LO register, and then we're going to store out T4 again, or no, then we move the low register, which is 20 times 3, and that's 60. That 60 gets loaded into T4, and that's it. Anyway, so that should that should get you going with the third assignment, and hope this helps. Thanks for watching.